Hi everyone. So in today's video, I would like to just kind of shed some light on what and how we are learning about lines and angles. And we spent some time last week learning about different parts of shapes, and we understand that points and different types of lines help us create different shapes, including polygons and so forth. And so this week we are adding on to that knowledge to help us understand that lines come together to make angles. And so we're going to talk a little bit today about how to identify different types of angles. And also, I want to just kind of go a little bit into how we use tools to help us measure angles as well, which will be something that we'll be getting to on Friday. So first and foremost, what we've been kind of looking at over the past 2 days, today and yesterday, was identifying angles. And so in fourth grade, they are going to be responsible for being able to look at an angle and or use some type of reference or benchmark to be able to identify or name the type of angle it is. So they'll have to classify it. That's one thing. And also they will have to be able to name the angle based on the letters that, the points that are on the lines or on the angles. Okay. So here's where it starts in fourth grade. So we're not at this point when we're just identifying or classifying them based on the type. We're not using a tool to measure it for a specific number. I know that when we look at an angle such as this, and actually I'm going to switch it over to this tool right here. When we see this, it's easy for us, for kids to recognize this angle out of many because it has a distinct shape. And so while it's not perfectly drawn on here is what I've done, this would be considered a right angle. And many of them know that the measurement of a right angle is 90 degrees. Okay. So, but one of the things that we start off with learning is how to identify an angle without associating it with a number. It's important for them to be able to do that. Now, because sometimes an angle it can look as close to that number as we think it does, but once we use a tool like this to measure it, it may not always match up to that. So first we'll just identify it. And to do so, we will use the tool that I just had available, okay? So in this first example that I have right here at the top, all right, number one, we've been learning that lines are made up of points, okay? They're made up of points that come together, and they can either make a line, which extends in both directions forever, or it can be a ray, which has one end point and it keeps extended in the other direction. Or it can also be a line segment, which kind of comes to a stop at both ends, which would be something like this, these two, between T and L. Okay? We also have learned about endpoints. But what I'm going to do is we are going to determine what type of angle it is. And just as a reference, we're going to use this tool. Okay? And again, it's not perfectly drawn, but we're going to consider this to be a right angle. Right? So one of the ways that's helpful, and I gave the kids each one of these today, is to kind of use it up against the angle itself. So the way that I taught them is to put the base of the angle on the base of the other angle right here, and just kind of line it up based on that. And this would be the corner or the vertex of that angle where the two rays come together. So where they meet, or the corner of them, sort of like an elbow, you put that against that line. And I apologize for the glare. Okay? So here, now that that's lined up, we want to pay attention to this line right here, okay? The one that's extending up, or that's upright, that's the one we want to pay attention to, because this line, when you're creating different angles, it's going to move in one or two directions. It can go forward or it can go backwards. When this line goes forward, okay, it's attempting to reach towards the bottom ray right here, okay? And so what it does is, instead of extending open, it is closing. So imagine that being a door and it's closing some, okay? Or it's getting smaller. Now, if we go back to this position, again, keeping our eyes on this line right here, if this line were to lean backwards, it doesn't matter how much, then it's opening up more, okay? And because it's opening up more, it's becoming wider. It's wider open, okay? So with that said, when you have this right angle, if this line or this ray goes in this direction, right here, then it's getting smaller, and we would call that an acute angle. But if this line right here, it opens up and leans back to go wider, then we can call that an angle that's wider than a right angle, or greater than a right angle, okay? And there are two types of angles that will fall into that particular category. One of them will be an obtuse angle, and the other one will be a straight angle. But for now, we're looking at this, and as you can tell, sitting on that bottom ray right here, this line extends with that exactly, okay? And so we'll know that this is called a right angle. Okay, again, we're not worrying about measuring it with numbers at this time. And the kids also have to know how to name the angle based on the capitalized letters, or the points that are on the line. And what you want to do, if it's more than one point and there's one in the middle, then that letter will go in the middle. So we can name this angle, and that's the symbol for it. And we would go X, A, M, or it could also be angle M, A, X, or it could simply be angle A, which is here, and it would look like that. Not that, actually. For a 90-degree angle, we put the box in the corner. Okay? So this is a right angle, and these are different ways. So I would say angle A, XAM, angle MAX, or angle A. All right? So if we want to compare it to this one so that we're able to name it, we just put it on the line. It doesn't have to be the same size, okay? We want to put it on the line. And again, we're using our right angle as a reference to help us, okay? So this is the line we're going to pay attention to. What we're doing is imagining that this line is changing somehow, all right? This stays in its place, but if I were to do something with that line to match this, what's already here, to match this part right here, then what I'll need to do is put this on here and imagine what would we need to do for this to match that line. Well, in order for that to happen, this part of the angle, or this ray, it would have to go backwards and essentially lay flat. So we know that an angle that just lays flat across in this way, that is called a straight angle, because it makes a straight line. And then we would name it angle, and again, the middle point always stays that. We can name this angle TLR. Okay, again, using our right angle reference tool just to be able to identify an angle, what we want to do is put it on the base of the angle. Okay, let me show you what happens if I don't turn it the correct way. So if I just put it on the corner there, then the base of my right angle extends somewhere where there's nothing there right now currently. Okay, and right now I'm just trying to classify or name the angle that we found. Okay, now you have to turn this the right way, because if I turned it this way, even though this is lined up here, my line goes here and it's not, it's not connecting anything. You can look you will have to look in the opposite direction. I'm going to go this way first. So here, lining this up with the base part of it, you're going to use this part to help you determine what type of angle it is. So what happens is, again, you want to imagine, let's see if I can turn this off if that makes it better, maybe a little bit. Okay, so you're going to imagine this part of the line, it is going to meet up with the actual part of the angle that is drawn on the paper. In order for this to match up with that, it will have to lean back, because right now it's standing up straight as a right angle, but this would fall backwards and turn that way. So when an angle, when you have a 90-degree angle and it falls backwards, it's opening up wider. So an angle that opens up to be wider than a right angle, that is going to be an obtuse angle. As I mentioned to the kids, you just imagine, with this being at the base of it, if you can imagine that this line, if it were to fall this way, it's almost like it's trying to reach the other ray. But here, it's just kind of falling back a little bit. Maybe taking that side to move this way. It does work in the opposite direction. So if I turned it, I still have to put this on the base of it. And you would have to open this up here. This line would go in that direction to meet up with this one. So I'm looking at this part right here. So turning it back this way means that this is the part, and this would fall in that direction. Sorry guys about the lights. So again, we can still see, even though it's facing a different direction, that this line, it would have to be this way in order to be a right angle, but once it falls backwards, then it becomes an obtuse angle. And we would name this angle, okay, remember this is the middle vertex, that's the middle, so that stays in the middle. So it would be angle ROY, or angle YOR, or, and when it's an angle, you just kind of do a semicircle across it, or angle O. Using this tool as a reference, I'm going to show you first. If I were to put this here, it is not on any part of the angle. It's not on a ray. So I don't have a choice. I have to turn this around. Okay, so that could be an effective tool for me. On here, we have the bottom ray lined up with this part. And then imagine this would be a 90-degree angle. But what's happening to this line if it were to meet up with the other line that's already drawn? Well, I would have to fall backwards. Okay? If I were moving forward, it would be going this way and closing up. Okay? It's not closing, it's opening up, which means that it is going to create an angle. If it's opening up wider, that means it's getting larger. Okay, so if it's larger than a right angle, then it's called an obtuse angle as well. And then our name for it, again, remember to keep the vertex in the middle. This will be angle A, B, C. Could have named it CBA. Start on the other end, angle CBA. All right, or angle B. Now, here, quickly again, using our tool, and this is how we practice in class as well. We're going to use our tool to help us identify this angle. Again, lining up the bottom ray with the bottom ray of the angle itself. And again, we're using Daniel's strategy. So if I look at the back part of this right angle right here, I'm going to pay attention to where the line is going. Is it reaching for this line here? Is it bending towards that? Or is it opening up wider to go away from it? So it's growing if it's going backwards, okay? And so this line is not falling backwards, but actually going forward. Imagine bending down to get smaller. So this line, where it stops here, that would be smaller. So we would call that an acute angle. And you would name it based on the letter choices. So this will be angle J, I, P. Or angle P, I, J. Or angle I. And lastly, identifying angles. We're going to line it up on the ray at the bottom. Make sure that's lined up. And then, as we can see, if we were to take this part of the line and move it forward that way, then what we're seeing happening is it's getting smaller than the 90-degree angle because it's bending down. When you see that this line is reaching for or trying to get close to the other line or the bottom ray, then this is called an acute angle. And we would name that I, L. Oh, I was looking at this one. Sorry, that's not angle IL. That's just angle L. That's it. The other letter. Okay? This is how you identify angles, and we use this tool as a reference point to help us with that. Now, I do want to show you how we're going to go about using a protractor, which I'm going to introduce that to the kids. So, for all intents and purposes, just kind of reviewing how this tool is used. Okay, I want to try to stop the glare behind it. So on a protractor, okay, this is a tool that's helpful with measuring different types of angles or different size angles. This is probably one of the harder tools whenever, just throughout my career of teaching, that it took some time for kids to get used to using. Okay, I'll point out some of the misconceptions or mistakes kids usually make when using this. Number one mistake they make, some kids, is they have it turned backwards. If the numbers are backwards, that's an easy fix. You want the numbers facing up. And 90 will always be straight in the middle. You can always use that as a reference point, because if it's backwards, then that means you got to turn it around the other direction. Okay? Some protractors don't have words on them to let you know if it's turned in the wrong direction. So just be mindful about that number 90, used as a tool. Okay, number 2, all protractors will have some kind of point in the middle of it. This one happens to have a cross. All of them do not. But you will have like a little point here or a really tiny hole in the middle. Okay? I'll talk about how we use that in a moment. The other thing you'll notice, and here's the other thing that usually trips kids up, is that it has numbers on the inside and it has numbers on the outside. Okay? The difference is this. You always want to make sure when you're starting off, you start at 0. Okay? There are numbers on the left starting at 0. Again, it goes to 90 and it keeps going. So you stay on the bottom track from 90 all the way up. If we're counting by tens, and it goes to 180. Okay? Now, let me show you how to use this tool to measure it. Number 1, when we place this on the angle, we want to make sure the hole or the center point right here is on the vertex of the angle, which is the part where the two rays or lines come together to meet to form an angle. Number 2, sometimes it will have a hole in there, and that might be helpful, but this has to be lined up with that. Number 2, if you look at this, okay, going straight across, that measures 180 degrees and or 0. Okay, so that's where it starts. So we want to line this up on the bottom ray, just like we did with this right angle tool right here. Okay, so let me show you how to do that. So we're gonna go to, I'm gonna go to this one right here. All right, and your very best efforts has to be to get this lined up with the vertex, okay, of the angle. And you want to put this on top of it. The lights are automatic, so I'm not moving very much in the classroom. It keeps turning on. So line this up on top of that. Place it on top. But then you want to make sure those crosshairs right there, that they go across this line. So you want to get that there, where that cross is. Now, you can see it underneath there, but right here is my red line that I trace right here. And you want to keep that on there because that's going to help us with measuring. All right? So what we're looking at is this. Always find your 0. Always find your 0. That will help you, help some kids who have made this mistake not start at 180. Always find your 0 to start with, okay? And our 0 is right here. That should be lined up with your arrow, okay? So I had to push it up just a tad. So I push the arrow over because, remember, this is the part that goes on forever, and that's on our 0 right now, keeping it steady, okay? And that's right here. So what we want to do, now that we have this lined up with that, is we're going to stay on the track where the 0 is, and that's on the top row. We're going to keep going all the way around until we get to this line right here. So we're going to start here at the 0, and we're going to keep opening up. Imagine somebody opening their mouth, a crocodile opening its mouth all the way until you get here. I just extended that line in red so it can probably be seen a little bit better. Okay, so if I do that, it'll be helpful. So I'm going to start at 0 right here, and we're going to stay on the track until we reach that line. 20, 30, 40, 50, 60, 70, 80, 90. So if the line was right here, straight up and down, that would be my right angle, but it's not. So 90 is always going to be in the middle. But then after 90 is 100, because I'm counting up by tens. And I'm going to keep going until I've reached my destination. So what it appears to be is that the second line, as it opened up on the side, opened all the way up to 140 degrees. 140 degrees. Okay? And we all know that 140 degrees is greater than 90. And that is why we call it an obtuse angle. So once again, where we started was, we didn't start right away measuring this. Kids have to have a benchmark or reference so that they know if this is greater than a right angle or less than a right angle, equal to a right angle, so on and so forth. And they have to know how to classify it without using this tool. This is a great way, a stepping stone or a scaffold for the kids before they start using this tool. Okay? So in this case, that's 140 degrees, all right? Let's go to this one. I don't want to do another obtuse one. I'm just going to, for the sake of the time in the video, I'm going to go down to this one right here. We're going to measure that, okay? So again, just as if I were lining this tool up on the bottom line, we want to make sure that this ray at the bottom is lined up on our protractor with that part there. So my hope is on the video, this shows up a lot easier than the black does. So I'm going to trace that over in red. And this part lines up with the vertex of the angle, and then it lays across that ray at the bottom. Okay, so that arrow should be lined up, and our starting point is 0. Okay, so with that said, holding this steady so it doesn't move, a good idea would be, because I know I'm starting at 0, I'm going to stay on that track, but the best I can, I'm going to extend my line just a bit, just so I can see easily what number it's close to, okay? So again, we start at 0. Always find your 0, and we're going to stay on that track and count up. So we're at 10, 20, 30, 40, 50. If I were estimating, I would say 60, but because I want to be just a tad bit more accurate, this is 50. In the middle right here is 55, and you may not be able to see each tiny little line after that one, so I'm going to do 56, 57, 58. Okay, so this angle, the acute angle JIP, it measures 58 degrees. Or I can say angle JIP measures 58 degrees. Okay, let's do one more for acute. You don't want to, just to see, all right, how small they can get. This angle, trying to get the lighting just right. Let's see. All right, so there's a glare that keeps coming, so I'm trying to get the lighting just right as we wrap this up. So here's our angle down here. As we pointed out before, we already know it's acute because we use our little reference tool to see that it falls smaller or closes up towards the other ray. We're using the protractor to measure it, line it up on this bottom line or the bottom ray, here that's helping form it. And you want to put this little center section on the vertex of the angle and line it up so that that bottom ray reaches all the way over right here to the 0. 0 is always your starting point. That's how you don't get it confused with the numbers on the inside unless it was pointing the other way. Okay, actually I think I will go back to the other angle. So this is 0 right here. And what we want to do is we're trying to see where does it go. Now this one kind of covers up the numbers, so we just got to kind of imagine where that is. Okay, so this is 0, and staying on the inside of it, I'm looking at about right here. If I can use color, keep trying to switch it out. I may be off just a tad. I think I might be off just a little bit, okay, where I extended it. So this is 0, 10, 20. That's 20, and that's 30. So I know it's less than that. And it looks like the halfway line right there in the middle between 20 and 30 is 25. So this is 20, that's 25, and that's 30. So this angle, or angle L, is about 25 degrees. Okay? Now, I think it's probably important, I know I was wrapping up, to show you what happens when the angle points the other way. The kids are asking some great questions, and today Christian asked, can the angle be facing the other direction? Yes, absolutely it can. Up, down, left, right. So when that happens, all right, tracing this in red, you have to know how to adjust when it comes to the protractor, okay? Again, same steps. This has to be on the vertex of the angle and lined up with the bottom ray, okay? Or lined up with one of the rays, okay? So then we have it there, but now the line is pointing in a different direction. But you always keep the same rule. Find your 0. Find the 0. That helps you to remember which side or which numbers to count. So we're looking here and we're finding our 0. The 0 is now on the inside track. Okay? So that means we have to go stay on the inside as we're counting our numbers. That's straight again. So we're here at 0. And we'll keep going around, because I haven't gotten to that line yet. I'm at the 90. And I'm noticing if I'm here at the 90, but it's going to keep getting wider and laying back. So that's how I know it's obtuse. And we keep going at the top. On the inside, not the top. Because if I was at 90 and I go to 80, that's getting smaller. Okay? So I'm at 90, 100, 110, 120, 130. And this is 140 here, but it looks like it's just a tiny smidge past that. Okay? So this is how we kind of extend it so we can be a little bit more precise with it. And that ended up being 144 degrees. Okay? So that's how we can use the protractor to measure the angles to the closest degree. And even though we can see this is a straight angle, okay, you just have to make sure you're getting that lined up on that line right here, okay? And because that goes straight across, I don't have to, the angle doesn't move, or none of the rays move in any direction. So that's how we know an angle, a straight angle, measures 180 degrees. Okay? And just as another connection, yesterday, Tristan asked, we were talking about what degrees are, and he made the connection. He asked the question when we were talking about different types of angles, and he says, well, how much or what type of angle is a circle? I thought that was a fantastic question for Tristan to ask, okay? And so I pointed out to him that with a circle, okay, that's not an angle in itself. So I'm going to use this compass to draw one on here, just to kind of illustrate why these kind of questions and connections matter more than just jumping to a formula. It's really important for kids to kind of understand how all these parts and pieces fit together. So within a circle, which I pointed out to them, we're getting to this part. This is what we're building up to. A circle measures 360 degrees. Okay, that wasn't the point of the lesson from yesterday, but when he asked that question, I knew that it would be a great reference point for us to go back to and talk about, because we've talked about fractions before, and we know that fractions are parts of a whole. And so I took the opportunity yesterday, just making this a center point here, to say that to make the connection, think of it like a pizza, right? When you have a pizza and it's cut into slices, they can think of that as like angles, okay? So the angles are like slices of pizza. They can be different sizes, right? So an angle is part of a whole circle, okay? And all of these angles, when you add them up, especially if it's multiple ones, then they're going to all add up to this whole total of 360 degrees. So everything has this little part. So if this part had a certain measurement, and let's say we had a different angle that was here. So from here to there, all right, that's a huge angle, which if we look at it differently, we can see that this right here is an obtuse angle, okay? Because if we line it up on there, there's our reference point, okay? This line would have to bend backwards or open up wider, and that's obtuse, okay? So all these little things matter so much, okay? And they just make a difference in terms of how the kids understand why something else means something else. So it's not just important for a kid to look at this and say, oh, that's 90 degrees. They not only need to know the name of it is a right angle, how to name it using the letters there, but they need to also understand how to use this angle as a benchmark to measure the sizes of other angles, and not just talk about them in terms of numbers, but if it's greater or wider or smaller than that, then they can kind of truly try to make sense of all the things that we're doing. Okay, I know this was lengthy. I didn't get to something else that I wanted to show. However, hopefully this tool, all the kids came home with this, and I did ask them to go back over the problems you had from last night. Since we dug a little bit deeper today into the topic of identifying and drawing angles, I wanted them to go back to make corrections on the homework pages that they had, and it was problems 1 through 16 on pages 603 through 604. Okay, let me know if you have any questions. Thank you.